Good evening. I know you guys are upset that we missed our 2-hour delay today, but just take comfort in knowing that we are officially 2 hours smarter than the Lincoln County and CMS schools. Isn't that great? Take a minute and write down the date for tonight's notes, video notes. It's 1/7/13, and title it Elimination Method Part 2. We're going to look at some tougher type elimination problems other than what we did in class today. So remember, when you're starting elimination method, you want to use this method when you see that your problems are in standard form. So the linear equation is in standard form. Okay, and so remember that's ax plus by equals c. Okay, oops. Okay, so only if you look over here, you have x and y on one side together, x and y on the other side together. You want to make sure your variables must line up. So like variables. So looking over here, if I happen to have y here and x here, I'd need to move those around so that my x's are on top of each other and my y's are on top of each other. Okay, so they need to be lined up. Okay, the third thing I'm going to do, in case you didn't know, this is what you should be writing down for your notes, as we're looking for the easiest variable to eliminate, or we want them to cancel out. And in this case, we're going to have to make a situation so it cancels out. And that's why these are a little bit harder. So if you look here, we have 2 and 4, negative 4x. If I add those won't cancel out. I have negative 3 and 6y, those won't cancel out. And I have a 2 and a 6, and those won't cancel out. So I have to look at what can I do to make either the x's cancel out or the y's cancel out. So if I look at the x's, in order for them to cancel out, they need to be the same coefficient or number. So this is a 4. I could make this a 4 by multiplying it by 2, and then those would cancel out. And the same thing here, this is a 6, but I could make this cancel out if it were a 6, so I could multiply by 2 here too. So either case it works. So what we're going to do is we're going to multiply through a common by 2 to make the variables cross out. So if I go over here, I'm just going to put a parenthesis around here, and if I multiply the x by 2, remember everything needs to get multiplied by 2. And I like doing this, so remember that that 2 gets multiplied by each one. So if we do that, so we have 2 times 2x, that's 4x. Bring the minus down. 2 times 3y, that's 6y, equals 2 times 12, which is 24. And then we're just going to go ahead and write this one underneath it. Negative 4x plus 6y equals 6. Okay? So once we've done that, we need to add them. So in this case, oops, our fourth step to multiply through by a number that will cancel a variable. And you may need to, I put my head's in the way. Sorry, Grace, my head's probably in the way. I'm going to scroll this up a little bit so you can see it. But I did remember my head was in the way. That's good, right? So the fourth one is to multiply through by a number that will cancel out a variable. And then our last step is going to be add each column. Okay? And by each column, I mean each one of these. Okay? So you should have 5 steps written down. If you need to, pause the video and get them written down. Okay? And I'm sorry about my head being in the way. All right, so going back to this, I'm going to add 4x minus 4x, that's 0. 6y minus 6y is 0. That equals 30. So I have 0 plus 0 equals 30, or 0 equals 30. Is that a true statement? 0 equal to 30? No. And so because this doesn't work out, this tells me this is not a consistent equation. So if it's not consistent, we have 2 other options. It can either be inconsistent, meaning they're parallel, or it can be dependent, meaning they're the same. So if we look over here, these are the same, but my constants are different. So that means these are not the same variable, right? If they're the same, or excuse me, same equation. If they were same equation, this would have to be 24. So they're not the same, so they're not dependent. So you must conclude that these are parallel lines. Therefore, they have no solution. Okay, so I threw that one in there on purpose to show you an example of how when this doesn't work. Okay. Okay, so let's look at another example here. Let's look at this equation right here. Here, my x's and my y's are lined up. They're in standard form because x and y are on the left side. So I know this is going to be an elimination type method problem. Here, I should recognize that. All right, so I changed that problem out. I didn't like that one. That didn't show me what I wanted to show you. All right, so I have a new problem now. All right, so I'm going to rewrite this because I don't like how they're like spaced out funny. So we have x minus 2y equals 3, and we have negative 5x plus 10y equals negative 15. Okay, so looking at this, they're both in standard form. Okay, I would need a 5 here to cross these out. I would need a 10 here to cross these out. And I have the same problem I wanted to have before. All right, so we're going to go through again. And I can just multiply through by 5, because remember there's a 1 there. So I'm going to multiply everything by 5. So boop, boop, boop. And so that's going to give me 5x minus 10y equals 15, right? And then this is going to be giving negative 5x plus 10y equals negative 15. I wrote that really sloppy, I'm sorry. Let's see if I can fix this. There we go. That equals 15, right? All right, so here we have negative 5, or positive 5x and negative 5x, that's 0, plus negative 10y and positive 10y, that's 0. And make sure you're applying the negative in front of that. And then we have 15 and negative 15 is 0. So I get 0 equals 0. Is that a true statement? Is 0 equal to 0? It sure is. So because the variable is crossed out, and that is a true statement, this must be dependent, meaning they're the same line. So if they're the same line, my answer should be all real numbers. Or they have the same, we said infinite solutions, okay? So here, my variables actually crossed off like last time, but the difference was this was a true statement. So that tells me that the variables are gone, so there's no point of intersection to find, but because my answer is true, that tells me it's a dependency. And if you look at this, if we were to multiply through by a negative 1 here, this would become 5x, which is the same as this. This would become negative 10y, which is the same as that. And this would become positive 15, which is the same as that. And so they actually are the same line. Whereas up here, when we did the math, we had 30, or 0 equals 30, which is not true. So because this is not true, they're parallel lines, and that's the solution. You might want to write a couple of notes about that. If the inequality is not true, it's parallel, no solution. If the inequality becomes true, then it's a all real numbers type situation. It's the same line, okay? And then we're going to go through one last problem. Okay, and so we'll look at the last type of problem I want to show you. Okay, so here again, we look and they're both in standard form. They're both lined up, so we have to figure out what the easiest variable is to eliminate. So looking at this, I can't multiply anything by 3 to be 4, and I can't multiply anything by 4 to be 3. So I have to think of a multiple they both have in common. So I could make these both 12 by multiplying this by 3 and that by 4. Or I could look at my y. My y is easier. I can't multiply these to be 5 or 2. However, they both have 10 as a multiple. So I could multiply this by 2 and this by 5, and then they would both be 10. So this one's kind of a tricky one because there's no easy way to do it. You're going to have to multiply the top and bottom by some number. So it really doesn't matter. For some reason, I like to see these y's go away. So what I'm going to do, is I'm going to multiply this top by 2. And remember, everything goes by 2, right? So that's going to give me 8y, or 8x, plus 10y equals negative 8. Okay, so I'm making my variable 10. So to make this 10, I have to multiply everything by 5. So in these cases, you're going to multiply the top and bottom. So 5 times 3 is 15x plus 2 times 5y, or 2i times 5 is going to give me 10y equals, and then 5 times 1 is 5. Okay. Now right now, 10y and 10y, they're both positive, so neither one of those is going to cancel out. So I need to multiply through by a negative, and it doesn't matter which one I do. I'm just going to pick this top one. So I need to multiply the entire thing by negative 1. To save a step, if you can see that ahead of time, we could have just multiplied through by negative 2. Okay. So this would give me negative 8, negative 10, and positive 8. So now when I add them up, I have negative 8x and 15x, excuse me, and that, was that give me 7y? And then negative 10 and positive 10y is going to give me 0. And then 8 and 5 is going to give me, what is that, 13? Okay. Oops. So I noticed this isn't working out nicely, which they don't always do. But then I went back and realized I made the same mistake I told you not to make. That's the most common mistake. So it's a good example. Here I multiplied 2 times 4x and I got 8x. 2 times 5y, I got 10y. And then I forgot to do the 2 times the 8. So this shouldn't be positive 8. This should be 2 times 8, which is 16. Okay. So now I have 16 plus 5. This is a positive. Doesn't look positive, but it is a positive. That's going to give me 21. Now that looks better. So then I just divide by 7, and x equals 3. So I know these intersect at 3 and some other y. So again, I'm going to plug this 3 in. I could plug it in these equations or these equations, whichever one looks easier. I'm just going to plug it into that bottom one. 3 times x, and we know x is 3, plus 2y equals 1. So this is going to be 9 plus 2y equals 1. Minus my 9, that's 0. Bring down positive 2y equals negative 8, and then divide by 2. So my y is negative 4. So these intersect at 3, negative 4. They're a consistent equation. All right, sorry that was a little long. I apologize. Have a great night. See you in the morning.